My name is Charlotte.
And my name is Abby. We were co-notebookers for Team 9962NA Lemon Pie during the over-under season.
We just graduated, and with the goal of creating a living resource for our sister teams while also addressing some of the regional curiosities surrounding our notebook, we've decided to share our documentation from the 2023-2024 season. It is important to note that while our notebook earned us a couple awards in a very competitive event region, it is just one take on the engineering notebook for VEX Robotics, and is by no means a world-class notebook or perfect example.
The first thing almost every VEX notebook resource will point you to is the rubric. This is the scoring guide that judges use to evaluate the content of a notebook. It can seem pretty overwhelming at first, but it tells you exactly what the judges are looking for to receive full marks in each category. The rubric largely follows and encourages the use of the engineering design process.
The engineering design process is a cycle of steps used to solve a problem. Following the design process to build your robot will help you make informed decisions and accounts for a large portion of the points on the notebook rubric. Top-tier teams will use the design process naturally.
The first step in the engineering design process is identifying the problem. This step is all about clarifying and understanding what you are trying to accomplish. You must do this for the game and season overall, as well as for individual challenges throughout the season. The first big problem you need to identify in your notebook is the game. Before you begin building or coding, it is important to analyze the game manual and understand the rules, what you must do and what you can't do. To understand how the game is played, you'll look into the SG, SC, and G rules, and to understand robot requirements and restraints, you'll want to analyze the R rules. Once you've broken down the game, you will need to equip your robot to complete certain tasks, manipulate game elements, negotiate the field in some way, fulfill autonomous win point tasks, you name it. Before researching different solutions to a sub-problem, you must define what exactly the problem is, what a subsystem needs to be capable of, what you want to accomplish with code, how the game manual restricts you, and so on.
When brainstorming solutions, consider what you could program or build to solve an aspect of the game and identify some potential pros and cons. Always list at least 3 different solutions to the problem, since this is what the rubric asks for, and always credit your sources.
When selecting a solution, you may use a decision-making matrix. Before filling out a decision-making matrix, you should set criteria to help you determine what features you prioritize in a solution. This could be things like motor usage, size, weight, or how well a solution works with an existing aspect of your robot. Optionally, you can weigh your criteria depending on what features are most important to your team. After a decision-making matrix is complete, make a plan to implement the winning solution. This can be done by drawing a detailed sketch of your build of labels, making a CAD model, drawing a map of the field with the route your robot will follow, or writing some pseudocode. This is also a good place to include a perceived materials list if applicable.
When recording the steps to build or program a solution, use a mix of words and pictures to help explain. Don't just put a picture of your final build or code, show the reader how you got there. We found it helpful to clearly mark pictures using circles or arrows to emphasize what we are referencing, since there can be a lot going on in an image, making it hard for someone who wasn't there to know where to look.
When communicating how you tested a solution and evaluated its success, make sure to state what you are testing and what the purpose of your testing is. Record how you will measure if a trial is successful and the efforts you will take to ensure a controlled testing setup. Repeat your test multiple times and collect data as you go. And note if you make any changes between trials, like starting your robot in a new spot, turning up the speed, etc. The current notebook rubric only asks teams to include testing results, but one of the things we were repeatedly praised for by the judges was our use of the data analysis process in tandem with the engineering design process. Every time we collected data, we would record our quantitative and qualitative analysis of the results. For our quantitative analysis, we would ask ourselves questions like, what was the success rate? How many times did our solution work? And how many times did it not work? This was us gathering and digesting the hard facts. For our qualitative analysis, we would consider questions such as what looked like it did or didn't work, and what were possible sources of error, to try and explain the results and determine next steps.
The final aspect of the engineering design process section of the rubric is to repeat the design process. After testing and refining your solution, you have come to the point in the design process where you need to determine if it is better to restart and pick a new solution or move on to a new problem if you are satisfied with your solution for an aspect of the game. Sometimes you don't need to repeat the entire design process. As you make small changes to improve your solution, we recommend recording those in short, refined solution entries. These could be things like tuning an angle or adding plastic backing, which are important to document but may not require you to rethink the solution from the ground up.
Some versions of the engineering design process have a final communicate results step. While not necessary from a rubric standpoint, we found that something would feel missing if competition notes were left out, and see it as a good way to reflect on robot performance on a broader scale. Before competitions, set a few goals to work towards as a team. During or after competitions, record match scores, ranking points, your final win-loss tie record, and how your skills runs went. These things give your team data points to reflect on and work to improve. If applicable, this is also a good place to mention team achievements, like winning an award. Finally, at the end of competition entries, we found it helpful to record general noticings or overall reflections of how a competition went to help inform next steps.
The rubric asks teams to document resource constraints, including time and materials. Your team should establish a method to track goals and accomplishments. A very popular method is the Gantt chart created by mechanical engineer Henry Gantt in the 1910s, which compares perceived productivity to actual accomplishments during a set period of time. Reflect on your goals periodically, every month, every robot you build, whatever your team decides is reasonable, and state whether you have met your objectives and what was left unfinished. To communicate material usage, make a materials list for each build and state your workarounds if you don't have a part you need. Make sure to explain how you are budgeting your plastic usage, air reservoirs, and motors, since these are all materials limited by the game manual.
Besides the engineering design process, the notebook rubric asks for innovation and originality. This essentially encourages teams to come up with and document original ideas. It also means looking for solutions outside of VEX or beyond the meta. For instance, during the over-under season, we did research on NASA's Mars rovers when looking for examples of six-wheel drives. More importantly, this section rewards teams who take design risks, come up with their own ideas rather than copying, and credit their sources when they do take inspiration from other teams.
Another rubric requirement not related to the engineering design process is usability and completeness. This means making it as easy as possible for someone reading your notebook to find what they are looking for. Judges only have so much time to look at and score each notebook, so showing them where to look is invaluable. We recommend using colored tabs to mark the different steps of the engineering design process. A repeating rainbow is also an easy indicator you've repeated the design process. Keeping and maintaining a table of contents is another way to help the reader. Always title your entries using buzzwords. For example, testing our drivetrain, alluding to the test solution rubric category, is better than June 4th meeting. Finally, we suggest teams consider writing a Dear Judges page or making a sample entry to help readers understand how to navigate your notebook. With a Dear Judges page, you can take the opportunity to briefly justify any formatting or structure decisions.
Team and project management can be shown in many ways. In addition to keeping Gantt charts like mentioned previously, our team kept a daily work log. This is a record of daily goals, accomplishments, meeting notes, and pictures where appropriate to show a team's progress in task assignments meeting by meeting. A daily work log can be more informal and kept as a supplemental appendix in your notebook.
The same rubric is used to evaluate all notebooks, whether physical or digital. Neither format is viewed more favorably from a judging standpoint, but competitions will require every team to submit their notebook in the same format. For instance, if a team keeps a digital notebook, they will need to print their notebook for competitions with physical notebook judging, while their notebook would remain natively digital for competitions with digital notebook judging. As far as which is right for your team, physical notebooks may be more standardized in some event regions. For example, Washington historically collects physical notebooks. They are also ready to go for competitions, and you can write in them up until the last second. Handwritten notebooks feel really authentic and can be good if you prefer sketching or handwriting. In comparison, the appeal of a digital notebook may be that it can't get lost, you can collaborate on the notebook, and it allows teams to explore modern documentation techniques. Despite all of those advantages, digital notebooks may require printing, which can become expensive depending on the scope of your notebook and if you want your pages in color. Our over-under notebook embarrassingly had a quadruple-digit price tag, so teams printing their notebooks should be prepared and have a plan.
We kept an informal daily work log with shorthand notes for a later and neater transfer into the notebook. This allowed everyone to be on the same page even if they weren't present at a meeting. Anyone on the team could fill out the daily work log. On our team, the two of us assumed the role of writing in the work log since we would be the ones processing the notes later. Since we also fulfilled the designing, building, and programming roles on our team, we rarely had to seek out information. But depending on your team structure, you may need to ask for missing details. By the end of the over-under season, we had over 300 pages of daily work log notes, which we never turned into the judges or showed anyone outside of our team. An article in the RECF library describes the difference between engineering notebooks and team journals. We consider our daily work log to be something like a team journal, since it housed all of our random notes and decisions, but was not suitable to be submitted for judging since it lacked the structure of the engineering design process. Still, a daily work log was a valuable resource for our team.
To make competition reflections easier, we printed out note sheets to record strategies we discussed with alliance partners and notes from matches. They were a very helpful resource both in the moment as immediate feedback and later when we were processing the competition in our notebook. The judges were often impressed by our expanding file folder where we kept match notes from the entire season. These notes served as a sort of breadcrumb trail of our interactions with other teams. By the end of the season, we had a good grasp on many of the teams local to us, what their robots were like, what their typical strategy was, stuff like that.
Several awards require the submission of an engineering notebook. One lesson we learned the hard way is that while a good notebook will get you interview opportunities, only a good interview will win you awards. If your team decides to put effort into creating and maintaining a high-quality engineering notebook, make sure to also review the interview rubric.
That was a lot of information. If you are just getting started notebooking and feel overwhelmed, our biggest tip is to get in the habit of writing a few bullet points describing what you did each meeting. Make sure they are all in one location and everyone on the team has access to them. We also suggest taking lots of pictures and videos as you make progress.
Frequently check your notebook against the rubric and don't be scared to ask for feedback.